Hello, hello. That's working. So is this working? Yeah. Okay, so I'm going to give a talk. It's not related to my own PhD. It's a very old result from computer science, but I think it's a very beautiful result, especially this proof by George K. Pullum. It's a specific proof that I think we can all benefit from taking some time out of our day to consider the classic results of computer science. So the presentation is called Scooping the Loop Snooper. No program can tell what another will do. I won't just assert that, I'll prove it to you. I will prove that although you might work till you drop, you can never tell where the computation will stop. For imagine you have a procedure called P that for specified input permits you to see where the specified source code with all of its faults defines a routine that eventually halts. You feed in your program with suitable data, P gets to work, and a little while later, in finite compute time, correctly infers where the infinite looping behavior occurs. If there will be no looping, P prints out good. That means work on this input will halt, as it should. But if it detects an unstoppable loop, then P prints out bad, which means you're in the soup. Well, the truth is that P cannot possibly be, because if you wrote it and gave it to me, I could use it to set up a logical bind that would shatter your reason and scramble your mind. Here's the trick that I'll use, and it's simple to do. I'll define a procedure which I will call Q, that uses P's prediction of halting success to stir up a terrible logical mess. For a specified program, say A once applies, the first step of this program called Q I devise is to find out from P what's the right thing to say of the looping behavior of A run on A. If P's answer is bad, Q will suddenly stop. But otherwise, Q will go back to the top and start off again, looping endlessly back till the universe dies and turns frozen and black. This program called Q wouldn't stay on the shelf. I would run it and fiendishly feed it itself. When it reads its own source code, just what will it do? What's the looping behavior of Q run on Q? If P wants of infinite loops, Q will quit. If P is supposed to speak truly of it. And if Q is going to quit, then P should say good, which makes Q start to loop. P denied that it would. No matter how P might perform, Q will scoop it. Q uses P's output to make P look stupid. Whatever P says, it cannot predict Q. P is right when it's wrong, and it's false when it's true. I've created a paradox, neat as can be, and simple by using your putative P. When you posited P, you stepped into a snare. Your assumption has really led you right into my lair. So where can this argument possibly go? I don't have to tell you, I'm sure you must know. The reductio, that cannot possibly be the procedure that acts like the mythical P. You can never find general mechanical means for predicting the acts of computing machines. It's something that cannot be done, so we users must find our own bugs. Our computers are losers. Thank you. Now, I'd love to take questions, but frankly I fear that soon I'll have Professor Pretchner up here. So I hope you enjoyed this presentation of mine, and if you have questions, we'll take them offline.